Good afternoon, everyone. So, today we will be doing a problem solving session and a concept clarification session on network bridge, LAN bridge, and LAN spanning tree. So, the topic for today is LAN bridge algorithm and LAN spanning algorithm. So, we will be going through network bridges, and then we will go through the spanning tree algorithm for LAN, and then we will solve some problems based on these topics. So the first topic for today is bridges and learning bridges. So today's first topic is learning bridges. So what is a network bridge? A network bridge is a computer networking device that creates a single aggregate network from multiple communication networks. This function is called network bridges. So there may be, say, take an example of this as there may be an office which has some networks, and there may be another office which will have another small LAN, but these small LANs cannot function independently of each other, so they have to be connected somehow, and this interconnection will give rise to the this internet or internet. But routing allows, so there is two ways of doing that. One is called network bridging and another is called network routing. So there are two ways. One is uh, a network bridging. First is a network bridging, and second is network routing. Now these two are independent things. Bridging is distinct from routing. So routing allows multiple networks to communicate independently and yet remain separate, whereas bridging connects two separate networks as if they were a single network. So the main difference is that bridging creates a network that is amalgamated from multiple networks. Usually the networks are amalgamated at the layer 2 or data link layer. So they are usually amalgamated at the layer 2 or data link layer. So this is bridging, whereas routing allows multiple independent networks to communicate with each other. So bridging creates a fused network which functions as a single network. Routing, whereas maintains the independence of the individual networks, whereas bridging creates a fused network which together form a big network. So there may be small networks which join together to form a big network, and that is the So now we see that the bridge see, now let's check out the network. So here we have network 1. So in network 1 we have, so here we can see this is network 1. So this is one network that has, so this is one network. So this has a phi 1 and a phi 2 and phi 1 and a MAC A. So this is station A on LAN 1. So this is station A on local area network 1. And then there is station B which is on local area network 2. So these two are independent networks. This is one network, this is another network. So these two are independent networks. These are not dependent networks. So these are independent networks. But they are joined together via a bridging mechanism called a bridge device. This bridge device copies the MAC and phi from the station A and also from the station B. Now the phis are usually kept separate. So the phi layers for this one and the phi layer for this one is kept separate, whereas the MAC layers are fused together using a bridge entity. So MAC layer so MAC layers are fused together using bridging so the MAC layers are fused together using a bridging entity. This is the layer of phi layer. So the now we come to the next question, that how are these MAC layers bridged. So we have established that the MAC layers will get bridged. As you can see, these MAC layers are fused together using the bridging entity. So in the OSI model, bridging is performed in the data link layer or layer 2. If one or more segments of the bridge networks are wireless, the device is known as a wireless bridge. So now we come to the part where there are multiple bridging techniques. So the first bridging technique is a simple bridge which connects two network segments, typically by operating independently and deciding on a frame by frame basis whether or not to forward from one network to another. A store and forward technique is typically used so as part of forwarding. The frame integrity is verified on the source network and CSMA CD. So we have discussed CSMA CD in length in the previous two classes. So CSMA CD delays are accommodated on the destination network. In contrast, repeaters repeaters which simply extend the maximum span of a segment. Bridges only forward frames that are required to cross the bridge. Additionally, bridges reduce collision by creating a separate collision. So, in a normal relay is a dump device. So, whatever data it gets, it will just forward that. So, A normal relay is a dumb device. Whatever data it gets, it will forward that. But a bridge is not a simple store and forward relay. A bridge is something different. So, a simple bridge connects two network segments and it simply does not store and forward. So, next our topic is uh, next topic is network bridging. So, simple bridges do store and forward. So, simple bridge. In simple bridge, there is simple bridge there is a store and forward mechanism. The packets arrive at a particular time and are so in simple bridge there is a store. The packets arrive at a particular time and are then forwarded on a on a packet by packet basis. Thus, when each packet arrives, the source MAC layer decides whether to transmit the packet to the destination MAC layer. The bridge also has a position avoidance mechanism of this. So now second part is multiport bridging. A multiport bridging connects multiple networks and operates transparently to decide on whether to forward traffic. Additionally, a multiport bridge must decide where to forward traffic. Like as a multiport bridge, like a simple bridge, multiport bridge typically uses store and forward operation. The multiport bridge function serves as basis for network switch. So network switch are built on the principle of multiport switching. So next is the multiport bridge. Hello. Ach. Again, very sorry for the interruption. I had some network issues. So, yeah, where was I? So we have covered single port bridge and multi-port bridge. Now multi-port bridge, single port bridges only know where to forward the packet, whereas multi-port bridges also have the when to forward the packet, and multi-port bridges have the idea of when to forward the packet and where to forward the packet. So with that in mind, we will move on to the next topic, that is so uh, yeah, LAN switching and bridges. So here we can see there are several different devices for interconnection. So one is a hub. Hub, we know, it collects all the devices, so collects all the data uh, from the various clients that is it is connected to, and so uh, yeah, so there are multiple ways of there are multiple ways of connecting hubs as hosts to hub. So or you can connect through page or router. So here there is a heterogeneous network. So this is a heterogeneous network. This is this is a heterogeneous network. This means that it has, this is a heterogeneous network. So this means it has multiple connections. So the hosts are connected to the hub. The hosts are connected. The hub is connected to a bridge, and the bridge is connected to a router. So the hub is basically a big switch. It contains all the clients, all the end user devices, and it all the traffic of the end user devices. So first we have hub. In hub, all the traffic of the end user devices. All the traffic of the end user devices are all the traffic of the end user devices are routed to the hub. So the hub just routes all the traffic that comes to the hosts. Whereas a bridge, as we have discussed earlier, connects networks, so connects networks, and a router connects the network to the internet. So a bridge might join, there may be another LAN network here. So if there is another LAN network here, say here, the bridge might join this network to this network. So if there is another LAN, say another LAN network here, so the bridge might join this LAN network to this LAN network. Whereas the router is connecting directly to the internet. So the LAN is not bridged with the internet, but it is not one with the internet. Instead, it is connected via the router and the gateway. Now, so Ethernet hub. Ethernet hub connects hosts to Ethernet LAN and connects multiple Ethernet LANs. So Ethernet hub connects hosts to Ethernet LAN, so local area network. So it connects all the end user devices to the local area network. So here the hub connects all the users to the local area network. The hub connects all the hosts to the end user network. So this internet through IP, LLC, and MAC, and through hub it will connect to another host who will connect. There may be another host here. So these hosts are all connected via hubs to LAN. So these connect multiple Ethernet. So this is how you are connected to the LAN. So connects hosts to Ethernet LAN and connects hosts to Ethernet LAN, and that is the job of hub. Now we come to bridge. A bridge or LAN switch is a device that interconnects two or more local area networks. So the hosts are connected to the. So here we see that the hosts are connected to the LAN. So the hosts are connected to the LAN, but the hosts are connected via the Ethernet hub. So the job of the Ethernet hub is to connect the hosts to the LAN. So hosts are connected to the LAN via the Ethernet hub. And what is the purpose of bridge? The bridge connects LAN networks, connects multiple LAN networks. How do I connect myself? so hosts are connected to and connects so bridges slash switches switches connect multiple such connect bridges switches connect multiple such LAN networks to the internet. Or it might connect to the internet, or it might connect to the intranet. That is, it might connect among itself. Connection among multiple LANs. So intranet is connection among multiple LANs without routing to the without connection among multiple LANs without routing to the internet. So here we have LANs. LANs are connected via bridges, and they're connected via to the multiple LAN. Now here we have bridges. So the IP is LLC, link layer control. IP goes to the link layer control in the next layer, and then we have basically the IP is at the network layer, and from there, so this is the IP is at the network layer. So IP is at the network layer, whereas this is at the data link layer, but data link LLC layer. So there are two sub layers of data link. One is LLC and one is MAC. So this is data link LLC layer, and this one is data link MAC layer. So this is data link MAC layer. Now this data link MAC layer connects to the MAC layer of the bridge. So the bridge only implements layer 2. Another important part is that bridge only implements layer 2. Now if bridge only implements layer 2, then they have LLC in that and MAC in that. So there is 802.3 is one network. So 802.3 is one LAN network, and another LAN network is 802.5. So there are two LAN networks. One is 802.3, another is 802.5. Now there is a LLC between 802.3 and 802.5 which connects the LLC of this bridge. The LLC of this bridge connects 802.3 network to 802.5 network, and thus these two LANs are fused together, and whichever packet that has to be sent to some user in 802.5. So previously in LAN, without any connection to the internet, previously in LAN you could only send the data from 802.3 to other users in 802.3. So from one device in 802.3 to other devices in 802.3. You cannot access any device that is not in 802.3 LAN. Whereas via bridge, what happens is one part of the bridge is in 802.3 LAN network, and another part of the bridge is in 802.5 LAN network. So it has both. So it has both 802.3 LAN network and 802.5 LAN network. Now if you want to, now 802.5 also becomes as if a network member of 802.3. So 802.5 becomes a member of 802.3. So whatever data comes to 802.5 that data gets forwarded to the LLC or gets uploaded to the LLC, link layer control. From there the LLC will go to 80, the LLC will forward the packet to 802.5 MAC of the bridge. So the bridge has both, so it will forward to the 802.5 MAC, and from there, since the 802.5 MAC is a part of the 802.5 MAC is a part of the since 802.5 MAC is a part of the other LAN network, so you could access the other LAN network also. So this ensures that there is a connectivity between the LAN network. Now, once you have that, so this is a single bridge. So the term bridge was coined in early 1980s. Today, the terms LAN switch or Ethernet switch are more used. So even though bridge is a technical term, the more preferred technical term is LAN switch. So you might have seen some switchboards in So we will be using the terms bridge and switch and LAN interchangeably. Now, a Ethernet switch is a packet switch for Ethernet threads, whereas a Ethernet hub does not perform buffering. So Ethernet switch is a packet switch, and there is a facility of buffering. So in Ethernet switch or Ethernet bridge, there is a facility of buffering, and also so Ethernet switch Ethernet switch or Ethernet bridge has buffering and collision detection properties. An Ethernet hub that connects all the devices in a particular Ethernet LAN network to the core network. The Ethernet hub does not have any buffering or collision prevention. So if two packets arrived at the same time in an Ethernet hub, then they are bound to collide. Now, once we have passed that, we can next focus on switch. So switch has CSMA CD and it also has a buffer, and thus it is a more expensive device compared to a hub. Now there is dual speed Ethernet hub. So dual speed hubs operate at I hate it. 40 মিনিট বাড়া ভালো লাগছে না। হেল্প মি গড। Sorry for the interruption again. So today I'm getting a lot of interruption for because of poor network from my side. So sorry. So next we will go to the next topic, that is routers. So routers operate at layer 3. So thus far we have learned about bridges. Bridges are operating at layer 2, which is the data link layer, whereas routers are operating at layer 3 or network layer. So routers interconnect IP networks. Thus we bridges interconnect NAC layers. Routers interconnect IP. So routers can interconnect IP networks. So routers do not force networks to form an amalgamation. So it happens at a higher layer where routers can where networks can function independently without amalgamating into a particular network. So there all the networks are independent, and the host network, which is the sender, and the host network, which is the receiver, are at completely different networks, may be located very far apart. They are completely different networks which are located very far apart, and thus routers provide connection to the gateway to the entire internet. So routers are also called gateways because they provide you gateway to the entire internet, whereas bridges just amalgamate LAN networks to form larger LAN networks. So, an enterprise network with a large number of LANs can use routers or bridges. So, if suppose there is a campus like IIT campus, so in that there are multiple departments, and each department might have a different LAN or local area network. So each department has a different local area network, and these local area networks of various departments are connected together to the wider IIT network using the enterprise bridges. So we have computers which are connected to edge switches. These edge switches are concatenated and they are connected to the via the bridges. So yeah. Next, interconnecting networks, bridges versus router. Each host's IP address in router, each host's IP address must be configured, whereas in MAC addresses of hosts are hardware. So in MAC the addresses are permanent, whereas in router each host IP can be configured. So IPs are dynamic in nature. If the network is reconfigured, IP addresses may need to be reassigned. Since IP addresses are dynamic in nature, so you cannot have a static IP. The IPs can change. Whereas here no network configuration is needed as the MAC is a static address for the device. And routing is done here in bridges. The routing is done by learning bridge algorithm or spanning tree algorithm. Whereas here it is done by algorithms like RIP or OSPF. So how does bridges work? So the bridges work with a three-part. So there is a three-part process to learning the operation of a bridge. There is the forwarding of frames, there is the learning of addresses, and then there is the spanning tree. So in forwarding of frames, each bridge, yeah, so in forwarding of frames, each bridge maintains a MAC forwarding table, and forwarding table plays the same role as routing table. So each bridge maintains, in frame forwarding, each bridge will maintain a forwarding table or routing table like routers. So entries have the form. So basically, you have a routing table, and in routing table, the bridges are since each bridge is maintaining a MAC forwarding table, so each bridge knows where to transmit the data, where to forward the data, sorry, not transmit, forward the data, and it also has an age which says that how old is this data. So because this is a dynamic allocation, so there needs to have an age. This age keeps track how old the data is, so that you do not have very outdated data. Next, after, so there is a frame forwarding. So in frame forwarding, basically according to the MAC address, so according to the destination MAC address, the bridge port is assigned. So if it wants to go to MAC address A, we go through bridge A. If it wants to go through MAC address B, it will go through bridge B. It will go through port B. So whenever it appears at port bridge 2, the data According to the destination address, it will be forwarded to port A or port B or port C. So routing entries are set automatically with a simple heuristic. Source field of a frame that arrives on a port tells which hosts are reachable. So how do you know that which addresses are accessible to this particular bridge? So this is updated using a simple heuristic that when the frames are coming to the bridge, it just keeps a note of where the frames are coming from. So if the frames can come from that place, that means that that particular device is addressable by the bridge. So it simply keeps tabs by keeping note of the source address of the packets. Now for each frame received, the source stores the source field in the forwarding database together with the port where the frame was received. So all entries are deleted after some time, and yeah, so it keeps note of the age, and after the age expires, all the entries are deleted. So for each frame received, the source stores the source field in forwarding database. So whenever there is some kind of a data that is coming, it will just store the address of that source packet. So wherever the packet is coming from, it assumes that since the packet is coming from there, that means that particular location is addressable from the particular bridge. So if there is a source A packet which goes to F, that means A is addressable by the LAN. And then there is source C and source E. So A goes to F, C goes to A, and E goes to C. Now from there, it will note that there is a LAN which connects A to B, and there is a LAN which connects C to D, and there is a LAN which connects E to F. Now here you can see, since you have to go from A to F, so A to F you have to go via bridge 1, and then you have to, since there is a C to A, there is a C to A connection, that means C is addressable. So reversely, when A packet goes through bridge 1, it will just transmit via the port 1, and it will go to port 2, and from there it will again be retransmitted back to F. So via LAN 2, the two bridges are creating a route for the packet to go from A to F. Similarly, the packet goes from E to C, or it goes from C to A. So C to A uses one bridge, E to C uses one bridge, whereas A to F uses two bridges. What do bridges do if some LANs are only reachable in multiple hops? So some LANs might only be reachable to other LANs via multiple hops. So you cannot go in one hop. Like if you want to reach from LAN 5 to LAN 3, you have to hop once through bridge 5 and again through bridge 2. So one example is, So what is the particular example? The example is LAN 5 to LAN 3. LAN 5 to LAN 3. So this is a particular example. LAN 5 to LAN 3. Now from there we will go to the next topic, that is spanning tree routing. So spanning tree protocol is a solution to prevent loops when forwarding frames between LANs. So spanning tree protocol organizes bridges and LANs as a spanning tree in a dynamic environment. So to learn more about spanning tree, of course, you have to know data structures. So we will not be going into details of spanning tree. So what it creates is basically it creates a tree. So it creates a hierarchy of bridges, and these bridges, so it creates a hierarchy of bridges, and these bridges are then basically we can, without forming any loop, we can directly route a packet from one LAN to another LAN. So this is a spanning tree protocol. So here you can see the more details of bridges. So bridges connect different LANs over ports. Now, so a spanning tree protocol. So here comes the spanning tree algorithm. The spanning tree algorithm's goal is to prevent forwarding loops, so that if I send a packet that goes to some intermediate A, that goes to some intermediate B, it shouldn't happen that it shouldn't happen that the packets that I send through intermediate A, then intermediate B, it should not loop back and come back to me. And thus, to prevent that, we use spanning tree algorithm. So, so how do the spanning tree work? For spanning tree, you elect a root node for the tree. So you elect a particular node to be root node. Now you grow the tree as the shortest distances from the root. So you grow take a particular root, and then you grow the tree from that root. So each initial condition, at the initial condition, each bridge thinks it is the root. So each bridge is running the spanning tree algorithm. So each of them is thinking that I am the root. So it is a kind of a decentralized approach. Now later bridges send only best configs. So wherever it gets the best configurations, best possible outcomes, only those ports are activated, and like that other ports are sent apart. So a distance vector is there. The distance vector is incremented. So when you increment the distance vector, you go down in the hierarchy. So ultimately, like that, when you run the algorithm iteratively, you end up with one node that is the root of the spanning tree, and all other nodes are at some distance from the spanning tree. So today LAN switches are multi-port bridges which are modern and are used to switch frames from one LAN network to another. So since the multiple LAN networks are connected, so LAN switches are used to switch frames from one LAN port to another. Okay, now so what are the what are the perspective of like pros and cons? Perspective means pros and cons of LAN switches. So LAN switches form an effective small scale network. So if you want to increase the range of your network, maybe a simple LAN network is not doing at all. then you should go for LAN switches. LAN switches design with so LAN switches are plug and play. They are designed to work as plug and play, but they don't scale well to large networks. So now the LAN switches form an effective small spiral network which are designed to work transparently with no host changes, but they don't scale well to large networks since these LAN switches are kind of like decentralized. So, since they are decentralized, they do not work well with a large network size, and also the spanning tree algorithm is a expensive algorithm, so running the spanning tree algorithm also limits the reconfiguration speed. So if the environment is changing, then the network needs to get reconfigured, but that is limited by the spanning tree algorithm, which is costly to implement. Now, once we have this, we will go to the assignments. We'll solve the assignments and we will end it there. Let's look at the assignments. Okay. Okay. So what is the primary, first question is, what is the primary purpose of spanning tree protocol in what is the primary purpose of a spanning tree protocol in a LAN network? So what to prevent, the main purpose of the spanning tree protocol is to prevent loops. So to prevent loops in network topology. So the packet that I am forwarding to some guy somewhere should not come back to me. That is the main prerogative of this LAN network. So here is to prevent loops in network. Next, state whether true or false. Given two configuration messages C1 and C2 during the formation of spanning tree in a LAN network, if the root IDs are equal, then C1 is better than C2 if the cost listed in C1 is numerically lower than the cost listed in C2. Okay, so this is a bit of a complicated question. So let's take a deep dive. Two configuration messages C1 and C2. So there are two configuration messages during the formation of spanning tree. So during the formation of spanning tree, the various bridges communicate with each other in the as the so so what I'm saying is that C1 and C2, so during spanning tree formation, since it is a decentralized process, there is constant exchange of configuration messages to make sure that the what is that the tree is forming properly. So If the root IDs are equal, then C1 and C2, so if they are both at the same level, so root ID equal means in this current iteration of the spanning tree algorithm, they are at the same level. So they are at the same level. So if they are at the same level, that means C1 will be better than C2 if cost is lower. So since they are all at the same level, and what you need to do is you need to differentiate between them, so that at the next iteration you can create two separate levels. So if you want to create two separate levels, you will of course look at the cost. So if the cost is lower, then C1 is superior. Next, how does a no-frills bridge, that is a simple bridge, how does a simple bridge differ from a router? A bridge operates at the physical layer. Nope. A bridge connects LAN segments. Nope. A bridge uses MAC segment. A bridge connects LAN segment. Okay. It's a while the router connects different IP subnets. So yeah, this can be a correct answer. Sorry. A bridge uses MAC addresses to forward packets, while router uses IP addresses. Okay. So they operate in the, since the bridges operate in the same IP subnets, in the different IP subnets. So the bridge does not use MAC addresses to forward packets. So it is no-frill bridges operate at the data link layer and connect LAN segments within the same IP subnet, while routers operate at the network layer and connect different IP subnets. So the correct answer is option B. Now, next question is, consider the LAN network in figure 1. After the learning process, the configuration at B1 is, so the configuration at B1 is one port has A and Q, and another port has D, M, K, T. So using B1, the left port of B1, you can connect to A and you can connect to Q. Whereas using the right port, you can connect to D, M, K, and T. So it is AQ and KDMT. So on one side it's AQ and on another side it's KDMT. Now consider the LAN network after the learning process. The configuration at B2 is, so at B2 it is, at B2 means at bridge 2. So you have AQDAM on one side and KT on another. So AQDM on one side like this. D, okay, AQDM on one side and KT on another. So C. So for bridge 1 you have AQ on one side and DMKT on another, and here you have AQDM on one side and KT on another side of the port. So here in bridge 2, port 1 connects AQDM and port 2 connects KT. So it's AQDM and KT or DQMA and TQMA. Now consider hosts A, B, C, D, E, F and learning bridges B1, B2, B3, B4 with their corresponding port numbers marked as shown. Assume that forwarding tables are empty for all the bridges. So all the bridges have empty forwarding tables. Also assume that entries added to each forwarding table do not have timeout. Okay, so there is no age entry, and after the age, so there is no this concept of age running out, and your table getting wiped through. So Next you have these devices, hosts, and you have this learning bridges. Now host A sends a message to host B. So host wants A wants to send to B. So which bridges receive the message? So which bridges receive the message? Now host A will send it via port 1, and then there is something called flooding. So here we have to protect the concept of flooding. Let's look at the concept of flooding. So let's take flooding. So consider that layer. So here we have a network. Consider the two LANs are connected by two bridges. Bridge A and B flood the frame to LAN 2. Bridge B sees F on LAN 2 and copies the frame locally. So let's take our example and understand how flooding happens. Here host A sends a message to host B, but this message has two routes. From B1 it can go to B, or it can go to B2, then it can go back, or it can go to B2 and B3, then it can go back, and like that there can be a flooding. So if there is a flooding, then all the bridges will receive message. So the correct answer is option E. Now this flooding happens because the forwarding table is empty. So everyone doesn't know where to exactly send the frame. So everyone doesn't know where to exactly send the frame. That's why there is a flooding. Next, after the step taken at question 6, host E sends a message to host A. Which of the bridges received the message? So once, because the tables were empty, so there was a flooding, but once that has happened, there has been a forwarding table. Now host E sends a message to host A. So E sends a message to A. So E will forward B4 to B2 to B1. So B3 will now no longer need the message to get the message. So it's B4, B2, B1. Since we have a proper forwarding table. Now, after taking steps taken at question 6 and 7, now host D sends a message to host B. Which of the bridges receive the message? So now D sends to B, B sends to B. So now it will go via B3, B2, B1. Simple. So now it will go via B3, B2, B1. But since B has not yet been used, no message has gone to port 2 yet. So the bridges don't know about device B. So if they don't know, if ports, if bridges don't know about particular devices that are at the end of the ports, the particular ports of bridges, then it can to find the particular. So since B is not known, there will be some extent or there will be some flooding. So B1, B2, B3, B4 all will get the message. Now again another of the same question. So this time 6, 7, 8, whatever has been told in 6, 7, 8 has been done. Now at 9. Now host F sends a message to D. So is host F sends a message to D, it should go to before B3, B2. There B2, B3. There should not be any flooding. So it is before B3, B2. So question answer is question number. Answer is option number. I beg your pardon. Option number B. Next is after the steps taken at question 6, 7, 8, 9. Host C sends a message to F. So now C will send a message to F. So it will again go through only B2 and B4. So the correct answer is B2 and B4. So B1, B2 not, B2, B3 not, it's B2, B4. So that leads us to the conclusion of lecture problem solving session 11 corresponding to week 11 of analog communication, sorry, computer communication networks. And next week will be the last week for this problem solving session corresponding to week 12. So do join us next week, Tuesday 6 p.m. onwards. So for now, I will take your leave. Thank you. Have a nice day.